the beginning there was no sky, no stars, no sound, only expansion, silent, unyielding and infinite. Imagine it now as you rest the entire universe compressed into a single radiant breath. Then release, a quiet unfolding. Space itself stretching, cooling, softening. Within moments too brief for words, the fabric of reality bloomed outward, carrying with it all the potential for light, for time, for life. There were no galaxies, yet no suns to warm the darkness. Only a sea of raw energy, radiant beyond measure, where particles blinked into being and vanished again like sparks in a cosmic tide. Protons and electrons wandered freely, unable to join hands. The universe was young, dense, and filled with light that could not escape a fog of brilliance, trapped within its own creation. For hundreds of thousands of years, this light wandered in circles, scattering endlessly among the charged particles that filled the early cosmos. It was not yet a night sky. It was a glowing ocean, neither bright nor dark, just uniform and endless shimmer of possibility. As the universe continued to expand, the light grew weaker, stretched into longer and cooler waves. The fire faded into a deep, pervasive warmth. The temperature dropped from billions of degrees to mere thousands, and suddenly something new became possible. Electrons slowed, protons waited, and for the first time they joined, forming the simplest of all atoms, hydrogen, then helium. With that, the universe exhaled. This was the moment the cosmos became transparent, when light, once imprisoned, was finally free to travel. Those first photons are still moving now, endlessly crossing the depths of space, whispering the story of that ancient dawn. We call it the cosmic microwave background, the faint afterglow of creation, a veil of light that still surrounds us, carrying the memory of a universe that had only just begun to see. If you could listen to that light, not with ears, but with patience, it would sound like a soft, steady hum spread evenly across the sky. Astronomers have found it everywhere, a faint radiation that fills all of space, no matter where you look. In 1964, two engineers, Arno Penzias and Robert Wilson, were working with a radio antenna in New Jersey when they detected a persistent noise. They tried everything to remove it, checked the wiring, cleaned the equipment, even chased away pigeons nesting in the horn of the antenna. But the signal remained. It was not noise. It was the oldest light in the universe reaching them across 13.8 billion years. Every patch of sky, every direction still carries that same glow. The afterimage of the universe's first awakening. It is gentle now, stretched by cosmic expansion into microwaves invisible to the human eye. Yet it surrounds us like an ancient lullaby. In the stillness that followed, gravity began its quiet work. Tiny fluctuations, denser here, thinner there, slowly drew matter together. The cosmic fog, once even and smooth, started to ripple. In these faint ripples, the seeds of everything took root: galaxies, stars, worlds, and eventually us. The first age of darkness began, not a darkness of despair, but of potential. There was no light, yet every particle drifted in preparation, waiting for the spark of fusion that would one day ignite the stars. Imagine floating there in that early cosmos, an ocean of invisible hydrogen, vast and cool. There is no up, no down, no edge, only depth, only distance. The faint pull of gravity tugs at you, softly gathering matter toward unseen centers. Over millions of years, clouds begin to form, vast and silent, stretching light years across. Each one is a promise. Deep within those clouds, the slow collapse begins. Gas falls inward, pressure builds and temperature rises. And then, in one of the universe's most graceful transformations, gravity's weight gives birth to fire. The first stars are born. They burn brighter than anything that will ever follow, massive, unstable, and fleeting. They light up the universe for the first time, ending the age of darkness and scattering heavy elements into the emptiness. From their short lives and explosive deaths, new materials emerge. Carbon, oxygen, iron, the building blocks of everything to come. Every star that follows carries within it a lineage, a memory of that first cosmic generation. And every atom in your body, every carbon molecule in your breath, traces its ancestry back to that original fire. You are, in a very real sense, made of the first light. Meanwhile, far in the future, from that ancient dawn, on a small blue world, orbiting an ordinary star, creatures would one day look up at the night sky and wonder where it all began. They would map constellations, name the planets, and invent stories to make sense of the glowing points above them. They would build lenses and instruments to see farther, peeling back the layers of time to glimpse the first light again. Through telescopes like Hubble and Planck, through radio dishes and detectors, cooled to near absolute zero, humanity would learn to hear the faint echo of that beginning, the whisper that once filled all of space. And each time they listened, they would hear a familiar rhythm, expansion, cooling, creation. The same rhythm that echoes now in the silence of your own breathing. The universe, it seems, is not separate from us. It breathes as we breathe. It expands as we grow. Somewhere in that vastness, the early stars flicker. Their light, though billions of years old, is still traveling, still moving across unimaginable distances. Each photon carries a message. I was born when the universe was young. As you listen, imagine that light finally reaching Earth, striking the atmosphere, glancing off oceans, and for a brief moment, touching your eye. That ancient photon's journey ends in your awareness, a bridge between the first dawn and this quiet moment. The story of astronomy begins not with a telescope, not even with a sky, but with light itself, learning how to travel. Before time could be measured, before stars could shine, the universe was already preparing to be seen. And so tonight's journey begins there, in that first silence where everything waited to become something more. The first breath of starlight has just begun. In the deep, unlit reaches of space, the universe began to gather itself. After hundreds of millions of quiet years, the fog that once filled the cosmos thinned into a vast transparency. Gravity, patient and persistent, started its slow, invisible work. Tiny ripples in the early sea of hydrogen and helium began to draw themselves inward, small currents in a cosmic ocean. There was no light here yet, only potential. Cold clouds of gas, delicate as breath, swirled gently through the void. Over time, they thickened, pulled by their own invisible weight, spiraling toward collapse. Each motion, each whisper of movement was guided by gravity's unseen hand, the same law that would one day pull an apple toward the ground or bind planets to their stars. As these immense clouds condensed pressure built within their centers, heat began to rise. Slowly atoms, the same atoms that once floated free since the universe's first light, began to touch, to fuse, to change. When hydrogen met, hydrogen, something new, was born. The first stars ignited. It was not a sudden explosion, but a quiet transformation. The darkness, learning how to glow. Fusion began deep within the dense hearts of those clouds. Protons merged, releasing energy that radiated outward. The balance between gravity and light was struck. Collapse met resistance. Pressure met peace. The universe, for the first time, began to shine from within. These first stars, what astronomers call population 3, were immense. Some hundreds of times the mass of our Sunday. Their lives were brilliant but brief, lasting only a few million years before burning out in spectacular deaths. Their light pierced the darkness, spreading across the cosmic web like dawn spilling through mist. Through that radiance, the universe changed again. Ultraviolet light from these newborn suns swept away the last of the cosmic fog, making space truly transparent. The epoch of reionization, as scientists now call it, marked the second dawn of the cosmos. For the first time, light could travel freely across vast distances. The night was no longer silent. When these massive stars reached the ends of their lives, they did not fade quietly. Their cores collapsed, and their outer layers were thrown violently into space in colossal explosions known as supernovae. In that moment, new elements were forged: carbon, oxygen, silicon, iron. The universe, once made only of hydrogen and helium, now carried the seeds of complexity. In their deaths, the stars became creators. Their ashes would someday form planets, oceans, and living things that could look back upon them and wonder. Every element of your body, every atom of calcium in your bones, every bit of iron in your blood, was once born in such a furnace. You are the continuation of that early light, condensed into form. The universe was not yet full of galaxies, but here and there, the first clusters began to take shape. Stars drawn together by gravity formed vast glowing webs, structures that would grow into the galaxies we see today. Meanwhile, space between these gatherings stretched farther apart. The first starfields floated in expanding emptiness, connected by thin threads of dark matter, unseen but essential. If you could drift there now, through that early cosmic landscape, you would see points of light, scattered like the first sparks of a distant fire. The airless silence would hum with radiation, faint but endless. Light would pass you in streams, blue from the newborn stars, red from those fading away. It is here that time begins to resemble music. Fusion becomes rhythm, gravity, harmony. The stars do not compete. They converse, each one pulsing with its own frequency, radiating warmth into infinity. For billions of years, this exchange continued. New stars were born from the dust of the old. Clouds collapsed again and again, each generation refining what came before. From these cycles of birth and death, the chemistry of life itself began to emerge. Somewhere, amid the young clusters of the Milky Way's ancestors, one of those stars burned with steady brilliance, a quiet beacon among chaos. Around it, a thin disk of dust and gas began to swirl. Tiny grains collided and fused, growing slowly into something more substantial. The process that began with the first stars had set in motion another story, the creation of worlds. But before those worlds could form, the cosmos had to learn stability. The violent births of massive stars were giving way to more balanced, enduring ones, stars like our Sun, destined to shine for billions of years. Their steady light would provide calm after the turbulence of creation. Through the long ages that followed, light continued to stretch across space. The glow from the first stars still moves among the galaxies, their photons endlessly traveling through cosmic time. Even now, some of that light reaches us soft, ancient, carrying the memory of the universe's awakening. In observatories around the world, astronomers collect that faint light, tracing its fingerprints through the vast night. Each spectral line, each subtle color, is a record of those first nuclear fires. It is a language the cosmos still speaks, one of energy, patience, and creation. And as you listen, as you rest beneath your own small patch of sky, you are listening to that same unfolding. The quiet pulse of hydrogen burning into helium, the slow drift of galaxies, the soundless music of expansion. The birth of stars was not just the origin of light, it was the beginning of memory. Every flicker, every photon, carries the story of the cosmos written across time. When you look up tonight, the stars above you are both ancient and immediate, glowing reminders that even from silence, brilliance can rise. The universe has learned to shine, and in doing so, it has begun to tell its story. In the deep, unlit reaches of space, the universe began to gather itself. After hundreds of millions of quiet years, the fog that once filled the cosmos thinned into a vast transparency. Gravity, patient and persistent, started its slow, invisible work. Tiny ripples in the early sea of hydrogen and helium began to draw themselves inward, small currents in a cosmic ocean. There was no light here yet, only potential. Cold clouds of gas, delicate as breath, swirled gently through the void. Over time they thickened, pulled by their own invisible weight, spiraling toward collapse. Each motion, each whisper of movement, was guided by gravity's unseen hand, the same law that would one day pull an apple toward the ground or bind planets to their stars. As these immense clouds, condensed pressure built within their centers. Heat began to rise. Slowly, atoms, the same atoms that once floated free since the universe's first light, began to touch, to fuse, to change. When hydrogen met hydrogen, something new was born. The first stars ignited. It was not a sudden explosion, but a quiet transformation, the darkness learning how to glow. Fusion began deep within the dense hearts of those clouds. Protons merged, releasing energy that radiated outward. The balance between gravity and light was struck. Collapse met, resistance pressure met peace. The universe for the first time began to shine from within. These first stars, what astronomers call population 3, were immense, some hundreds of times the mass of our Sunday. Their lives were brilliant, but brief, lasting only a few million years before burning out in spectacular deaths. Their light pierced the darkness, spreading across the cosmic web like dawn, spilling through mist. Through that radiance, the universe changed again. Ultraviolet light from these newborn suns swept away the last of the cosmic fog, making space truly transparent. The epoch of reionization, as scientists now call it, marked the second dawn of the cosmos. For the first time, light could travel freely across vast distances. The night was no longer silent. When these massive stars reached the ends of their lives, they did not fade quietly. Their cores collapsed, and their outer layers were thrown violently into space in colossal explosions known as supernovae. In that moment, new elements were forged: carbon, oxygen, silicon, iron. The universe, once made only of hydrogen and helium, now carried the seeds of complexity. In their deaths, the stars became creators. Their ashes would someday form planets, oceans, and living things that could look back upon them and wonder. Every element of your body, every atom of calcium in your bones, every bit of iron in your blood, was once born in such a furnace. You are the continuation of that early light, condensed into form. The universe was not yet full of galaxies, but here and there, the first clusters began to take shape. Stars drawn together by gravity formed vast glowing webs, structures that would grow into the galaxies we see today. Meanwhile, space between these gatherings stretched farther apart. The first starfields floated in expanding emptiness, connected by thin threads of dark matter, unseen but essential. If you could drift there now, through that early cosmic landscape, you would see points of light scattered, like the first sparks of a distant fire. The airless silence would hum with radiation, faint but endless. Light would pass you in streams, blue from the newborn stars, red from those fading away. It is here that time begins to resemble music. Fusion becomes rhythm, gravity harmony. The stars do not compete. They converse, each one pulsing with its own frequency, radiating warmth into infinity. For billions of years, this exchange continued. New stars were born from the dust of the old. Clouds collapsed again and again, each generation refining what came before. From these cycles of birth and death, the chemistry of life itself began to emerge. Somewhere amid the young clusters of the Milky Way's ancestors, one of those stars burned with steady brilliance, a quiet beacon among chaos. Around it, a thin disk of dust and gas began to swirl. Tiny grains collided and fused, growing slowly into something more substantial. The process that began with the first stars had set in motion another story, the creation of worlds. But before those worlds could form, the cosmos had to learn stability. The violent births of massive stars were giving way to more balanced, enduring ones. Stars like our Sun, destined to shine for billions of years. Their steady light would provide calm after the turbulence of creation. Through the long ages that followed, light continued to stretch across space. The glow from the first stars still moves among the galaxies, their photons endlessly traveling through cosmic time. Even now, some of that light reaches us soft, ancient, carrying the memory of the universe's awakening. In observatories around the world, astronomers collect that faint light, tracing its fingerprints through the vast night. Each spectral line, each subtle color, is a record of those first nuclear fires. It is a language the cosmos still speaks, one of energy, patience, and creation. And as you listen, as you rest beneath your own small patch of sky, you are listening to that same unfolding, the quiet pulse of hydrogen burning into helium, the slow drift of galaxies, the soundless music of expansion. The birth of stars was not just the origin of light, it was the beginning of memory. Every flicker, every photon carries the story of the cosmos written across time. When you look up tonight, the stars above you are both ancient and immediate, glowing reminders that even from silence, brilliance can rise. The universe has learned to shine, and in doing so, it has begun to tell its story. Across the newborn universe, starlight began to gather. Gravity, that quiet architect of everything, continued its invisible work, pulling stars toward one another, weaving them into luminous threads. Slowly, these threads wound themselves into great spirals, clusters, and halos. The first galaxies were taking shape, immense islands of light, adrift in an infinite ocean of dark. Imagine it from a distance, glowing structures stretching across space, each containing billions of stars, nebulae, and planets yet to form. Some were small, fragile like embers, others vast, rotating majestically through the cosmic void. Between them lay gulfs of nothing, spaces so immense that light would take millions of years to cross them. Yet within each galaxy, there was rhythm and order. Each one spun like a vast wheel. Stars circled, invisible centers, their orbits balanced by gravity and momentum. Within those centers, something strange began to form. Objects so dense that light itself could not escape their pull. These were the first black holes, ancient anchors around which entire galaxies would dance. In time, these gravitational cores grew into supermassive black holes, millions or even billions of times heavier than any star. Their presence shaped the galaxies around them, drawing matter inward and releasing energy outward. They were paradoxes of the cosmos, darkness that created light, destruction that sustained form. Meanwhile, the galaxies themselves multiplied and collided. In the vast theater of creation, they moved not as still portraits, but as living systems, drifting, merging, and transforming. Two galaxies might pass near each other, their mutual gravity stretching them into long glowing arcs, ribbons of stars flung into intergalactic space. Others might collide head-on, their stars passing harmlessly through each other, while gas and dust ignited in waves of new starbirth. Even now, billions of years later, this dance continues. Our own Milky Way is currently moving toward its nearest large neighbor, the Andromeda Galaxy. In about 4 billion years, the two will merge, forming a single giant galaxy, a slow, magnificent embrace lasting hundreds of millions of years. If you could watch this from afar, it would not be violent. Only graceful galaxies, blending like watercolor paints in a boundless canvas of dark. Each galaxy in its own way tells a story of balance. The push and pull of gravity, the rise and fall of light, the cycle of creation and dissolution. Within them, elements from the first stars mingle with new ones, recycled endlessly into planets, moons, and life-bearing worlds. It is here that the cosmic order begins to resemble something familiar. A pattern, a geometry, a quiet intelligence built from physics itself. Spiral galaxies with their sweeping arms and radiant centers mirror the shapes of storms, shells, and even the whirls of fingerprints. Elliptical galaxies glow like ancient embers, serene and stately. Irregular ones scatter their light like brush strokes across the night. When astronomers look up, they see not chaos but architecture, the universe building itself through symmetry and patience. Our own galaxy, the Milky Way, is one of hundreds of billions. It stretches about 1,000,000 light years across a luminous disk of stars, gas, and dust, rotating around a dark, quiet center. Every star you can see on a clear night belongs to it. Yet beyond, invisible to the naked eye, lie countless other galaxies, each with its own suns, its own planets, its own hidden histories. In 1923, a telescope at Mount Wilson changed everything. Astronomer Edwin Hubble studied a faint patch of light, once believed to be a nebula within our galaxy. But when he measured its distance using a type of pulsating star called a Cepheid variable, he discovered it was far beyond the Milky Way. It was a separate galaxy, the Andromeda Galaxy, and it shattered humanity's understanding of scale. In that moment, the universe grew from one island of stars to an ocean of them. Now we know there are more galaxies in the observable universe than there are grains of sand on every beach on Earth. Each one a city of light, each with billions of stars, and each with its own story unfolding over billions of years. When telescopes like Hubble and James Webb look deep into space, they also look back in time. Because light takes time to travel, what we see are not galaxies as they are now, but as they once were. The deeper we look, the younger the universe becomes. In the faintest smudges of distant light, we see galaxies forming in their infancy, small, bright, chaotic. The first structures built after darkness gave way to dawn. Some of that light has traveled more than 13 billion years to reach us. It began its journey long before the Earth existed, long before the sun was born, long before even the Milky Way had found its shape. Yet, tonight, it arrives here, striking your eyes, whispering across the void that distance cannot silence. You are in this very moment connected to the first galaxies that ever were. The starlight that falls on oceans, deserts, and forests is the same light that left those distant cities of creation. The photons have traveled unbroken through the cold corridors of space, never aging, never resting, just moving gently until they found you. It is easy to think of galaxies as distant or unreachable, but in truth, their story is already written within you. Every atom in your body, every molecule of air you breathe, was once illuminated by ancient stars. You are part of the same spiral, the same flow of time and energy that began with their birth. The galaxies may seem eternal, but even they have lifespans. Over trillions of years, as stars fade and fuel runs low, they will grow dim. Yet the pattern, the rhythm of creation and dissolution will continue. For every dying galaxy, another will take its place, born from the fragments of the old. This is how the cosmos endures, through transformation, not permanence. And so, as you rest beneath the night sky, remember this: what you see above you is not static. It is alive in motion, full of stories that stretch beyond measure. The Milky Way turning softly overhead, the faint haze of Andromeda glowing in the distance. These are not decorations, but the great unfolding of existence itself. Each star, each cluster, each swirl of light is a note in the universe's silent symphony. Together they compose the cosmic harmony we call the night sky. When you look upward, you are not looking out. You are looking back. Through time, through creation, through the memory of the universe itself. And what you find there, shimmering quietly in the dark, is the same light that has always been ancient, patient, and eternal. The galaxies drift on, their light still falls. And in that gentle glow, the universe continues to dream. Gravity is the silent choreographer of the cosmos, unseen, untouchable, yet present everywhere. It binds galaxies together, keeps planets in their paths, and draws moons into their elegant orbits. Without it, the universe would be a cloud of drifting particles expanding into nothingness. With it, there is pattern, motion, rhythm. It is easy to forget that gravity is not a force in the ordinary sense, not a push or a pull, but a gentle bending of space and time itself. Where there is mass, space curves. Where space curves, paths bend. A star's gravity shapes the movement of its planets, just as the curve of a river shapes the flow of water. In the great expanse of the universe, gravity hums like an invisible bass note beneath all things. It does not rush. It is patient, calm, and eternal. Imagine now the dance it conducts. Stars circle the centers of galaxies. Galaxies orbit within clusters. Clusters move through the cosmic web, drawn toward invisible filaments of dark matter. Each object follows its own rhythm, yet together they form a vast and graceful ballet. Billions of years in motion. Here on Earth, we feel only a small echo of that power. We sense it in the fall of a raindrop, the swing of a pendulum, the weight of our own bodies. It is constant, faithful, the quiet companion of every living thing. But in space, its influence is profound, sculpting the very architecture of existence. The story of gravity began long before we could name it. For centuries, people watched the heavens and saw that the same stars returned each season, that the moon moved in a steady rhythm, and that tides rose and fell with the lunar cycle. Yet it was not until the 17th century that a single idea united the heavens and the earth. In 1687, Isaac Newton published his Philosophia Naturalis, Principia Mathematica. In it, he described the law of universal gravitation, that every object in the universe attracts every other with a force proportional to their masses and inversely proportional to the square of their distance. With that one insight, the sky and the ground became part of the same story. The same law that caused an apple to fall from a tree also kept the moon in its orbit. Newton's equations worked beautifully. They explained the movement of planets and predicted the paths of comets. Yet centuries later, another mind would reveal that gravity was even deeper than anyone had imagined. In 1915, Albert Einstein introduced the theory of general relativity, a new way of seeing the universe. Space and time, he said, are not separate. They are one fabric, flexible and responsive. Massive objects do not pull on others with a force. They bend the fabric of space-time, and other objects simply follow the curves. A planet does not orbit a star in the way a stone whirls on a string. It falls continuously through curved space, endlessly descending but never reaching. To test this idea, astronomers watched the 1919 solar eclipse. As the moon blocked the sun, they measured the positions of nearby stars. Their light had shifted, slightly bent by the sun's gravity, just as Einstein had predicted. The universe, it seemed, was not rigid, but elastic, warping and flowing like a tide. That discovery changed everything. Now, when we look at galaxies, we see the curvature of space itself. When we watch planets move, we are seeing geometry in motion. When we measure time near a black hole, we see it slow, stretched by gravity's hand. Even the passage of time on Earth is affected. Clocks run slightly faster on mountaintops than at sea level. Every tick, every heartbeat is part of gravity's rhythm. In the great expanses between galaxies, gravity shapes invisible highways. The cosmic web, a vast structure of filaments and voids, connecting the universe like a living network. Within these threads, matter collects, stars form, and galaxies are born. Between them lie dark spaces where almost nothing exists, the quiet pauses in the symphony of creation. Our own solar system is one of gravity's most intricate compositions. The sun, massive and luminous, holds the planets in their orbits. Mercury races closest to the fire. Neptune drifts in the cold outskirts. Each world moves at its own pace, tracing a perfect ellipse through space. The moon circles Earth. Earth circles the sun, and the sun itself drifts around the Milky Way, completing one galactic orbit every 230 million years. Meanwhile, the planets interact, subtly tugging on each other with tiny gravitational whispers. These influences cause gentle wobbles and shifts, celestial conversations unfolding across millions of years. Nothing in the cosmos moves alone. Even light, the swiftest traveler in the universe, is not immune to gravity's touch. Around massive stars or black holes, light bends, curving in smooth arcs. This effect, called gravitational lensing, allows astronomers to see far beyond what would otherwise be possible. The gravity of a galaxy can act as a magnifying glass, bending and amplifying the light of another galaxy billions of light years behind it. Sometimes, this lensing creates halos of light rings and arcs that appear like faint ripples around distant objects. They are not illusions, but reflections of space-time itself, revealing the universe's deep geometry. Gravity is also a messenger. When two massive objects collide, such as black holes or neutron stars, they send ripples through the fabric of space-time. These gravitational waves travel at the speed of light, carrying the story of cosmic cataclysms across billions of light years. In 2015, scientists using the LIGO Observatory detected these waves for the first time, tiny distortions in space itself, passing through Earth like the faintest tremors. It was as if the universe had whispered, "I am moving." To think the same gentle force that keeps your feet on the ground can stretch and shake the entire cosmos, and yet gravity is not loud or impatient. It is steady, unhurried, and omnipresent. It allows stars to form, galaxies to hold, and planets to spin safely through the dark. It sculpts time, gives shape to light, and teaches the universe to remain connected, even as it expands, as you breathe slowly. Now imagine that each inhale is the draw of gravity, gentle, consistent, inevitable. It is the same motion that brings stars together, the same rhythm that keeps worlds aligned. Gravity is not the enemy of freedom, but the keeper of harmony. It binds everything, yet allows it to move. In its quiet persistence, it offers the universe balance. And in that balance we find beauty. The cosmos does not rush. It turns and drifts, gracefully held together by invisible kindness, the tender curve of space-time. Every point of light in the night sky is a story. A life that began in darkness, kindled by pressure and sustained by balance. Stars are not static ornaments, but living processes, the beating hearts of the universe, breathing light and energy into the void. They begin quietly within the cool embrace of interstellar clouds. In these vast nebulae regions spanning dozens of light years, dust and gas drift, waiting for a small disturbance. The passing shockwave of a nearby supernova, a ripple of gravity, or the slow pull of density, gathering upon itself. Where matter begins to fall inward, a seed is planted, a protostar is born. In the earlier stage, it is still wrapped in a cocoon of gas, invisible to human eyes, but radiant in infrared. Deep inside, hydrogen atoms collide with increasing frequency. Pressure rises, heat builds, and the core glows not yet from fusion, but from the gravitational energy of collapse. Slowly, the protostar begins to spin, flattening the surrounding gas into a swirling disk. Within that disk, planets may one day form. As the core temperature climbs to about 10 million degrees, the first spark ignites. Hydrogen nuclei begin to fuse into helium, releasing energy in the form of light. A delicate balance is struck. Gravity pulling inward, radiation pushing outward. The star awakens. It enters the longest and most stable part of its life, the main sequence, where it will spend the majority of its existence shining with calm precision. Our own sun is in this phase now. About halfway through its 10 billion-year life, it fuses 600 million tons of hydrogen every second, converting a small fraction of that mass into light and warmth. And yet, it remains perfectly steady, neither swelling nor collapsing, an equilibrium so exact that even a 1% change would reshape the solar system. Across the universe, billions of stars live out their quiet middle age in similar balance. The small, cool red dwarfs burn slowly, conserving their fuel for trillions of years. The larger, hotter blue giants blaze fiercely, living fast and dying young. Within these stellar furnaces, new elements are forged. Through nuclear fusion, stars build the periodic table piece by piece: carbon, oxygen, nitrogen, silicon, iron. Each layer within a massive star becomes a shell of creation, like the rings of a tree. When a star like our sun nears the end of its life, its core begins to run out of hydrogen. Fusion slows. Gravity starts to win. The core contracts, heating up again, while the outer layers expand into vast glowing shells. The star becomes a red giant. One day, billions of years from now, the sun will swell large enough to engulf Mercury and Venus. Its light will redden, its energy will change, and Earth will drift beneath skies of copper and gold. Then gently, it will release its outer layers into space, creating a shimmering shell of gas known as a planetary nebula. At its center, only the core will remain a white dwarf, hot and small, cooling slowly through eternity. For more massive stars, the ending is far more dramatic. When fusion can no longer support their immense weight, the core collapses in an instant. Atoms are crushed. The outer layers rebound, exploding outward in a brilliant supernova. In that single event, more energy is released than the sun will emit in its entire lifetime. The explosion lights up galaxies, scattering heavy elements across interstellar space. From those ashes, new stars and planets will one day form. And so the cycle continues. Light giving birth to light, generation after generation. The most massive remnants left behind by such explosions collapse even further, forming neutron stars or black holes. A neutron star is so dense that a teaspoon of its material would weigh billions of tons. Some spin rapidly, emitting beams of energy. Pulsars, cosmic lighthouses, flashing across the dark. Black holes, by contrast, disappear from sight entirely. Their gravity becomes so strong that not even light can escape. Yet even in their silence, they shape the galaxies around them. From birth to death, a star's journey is an act of balance and transformation. It converts the simple into the complex, the invisible into the radiant. It is both process and poetry, a manifestation of the universe's desire to illuminate itself. When astronomers study stars, they do not only observe their light, they read their life stories written in spectra. Every color, every frequency reveals something about a star's age, temperature, and composition. By spreading light through a prism, scientists can tell which elements are present, a cosmic fingerprint. The yellow glow of our sun tells of hydrogen and helium. The reddish light of Betelgeuse speaks of cooler gases and expansion. The pure white shimmer of Vega tells of heat and youth. Through light alone, we learn that stars are not eternal. They are evolving, aging, and eventually fading. Yet their collective glow fills the universe with continuity. Even as some die, others are born. Even as one fades, another ignites. Every second, somewhere in the cosmos, a new star flares into existence, and somewhere else, another releases its final breath, scattering its luminous ashes into space. The rhythm never ends. If you were to close your eyes now and imagine the sound of that rhythm, the pulse of creation, you might hear it as a quiet heartbeat, not the heartbeat of a single creature, but of existence itself. We live within that pulse. The light that warms your face, the photons that illuminate your world, began their journey within the sun's core, thousands of centuries ago, slowly rising through dense plasma until escaping into space. It takes a ray of sunlight about 8 minutes to travel from the sun to Earth, but tens of thousands of years to move from the center of the sun to its surface. Every sunrise, then, is ancient. Every shaft of light that passes through your window carries the memory of a long journey through the heart of a star. And when the day fades and you look up to the stars again, remember they are still living, still transforming, still shaping the fabric of time. Some are just beginning their story, others are ending theirs. Yet all share the same eternal purpose: to shine, and in shining, to connect. For stars do not only illuminate the darkness, they link it, bridging the silence between galaxies, carrying energy from the heart of creation into every corner of space. Every star is a point of awareness in the universe, a flame of physics, a poem of light, and through them, the cosmos dreams of itself. In the wake of every newborn star, the story of worlds begins. After the brilliance of ignition settles, a star is surrounded by the remnants of its own birth. A vast disk of dust and gas, still warm from the heat of formation. It looks like smoke, drifting through light, spinning gently in orbit, its particles colliding and clumping in the quiet choreography of creation. This is the birthplace of planets. At first, everything is microscopic grains of silicate carbon and ice colliding in the gentle turbulence of the protoplanetary disk. Each collision is a moment of chance, sometimes destructive, sometimes uniting. But where they stick, they grow. Dust becomes pebbles, pebbles become rocks, and rocks become mountains of matter that swirl and circle their parent star. These growing bodies, called planetesimals, are the seeds of worlds. They drift through the disk, attracting more material with their own gravity. As they grow, larger collisions become more frequent and more powerful. The heat from these impacts melts rock and metal, forming glowing oceans of magma. In the colder, outer reaches where ice can survive, the building blocks of gas giants take shape, cores massive enough to draw in thick envelopes of hydrogen and helium. Closer to the star, where it is too warm for ice to remain, rocky planets form, instead compact, solid, and eventually capable of holding oceans and atmospheres. From chaos comes order, from dust comes form. And so, across billions of star systems, this slow and graceful process repeats. Every point of light you see in the sky may be surrounded by worlds, each with its own orbit, its own chemistry, its own potential for story. Our own solar system followed this same cosmic blueprint. About 4.6 billion years ago, a cloud of gas and dust collapsed under its own gravity, forming our sun at its center. The leftover material flattened into a disk, and from it, 8 planets emerged, along with countless moons, asteroids, and comets. The early solar system was not peaceful. Worlds were still young, their orbits unstable, their surfaces molten and violent. Asteroids crashed into forming planets with unimaginable force, shaping landscapes and atmospheres. One such collision scientists believe tore away a piece of Earth, which later coalesced into the Moon. But over time, the violence subsided. Gravity sculpted, stability, orbits circularized, surfaces cooled, oceans condensed from steam, and skies began to clear. It was in this calm that the possibility of life appeared not as an accident, but as a continuation of the universe's patient unfolding. The very same processes that formed the sun and planets were guided by the same rules that governed the first star's gravity, chemistry, time. The universe had been refining its art for billions of years, and here, on one small planet among billions, it found a new way to express it through consciousness. Yet even before life, the diversity of worlds was astonishing. There are planets larger than stars, their surfaces glowing faintly with heat from their own collapse. There are small rocky orbs tidally locked, with one side forever scorched by sunlight and the other in endless night. There are gas giants, with storms that have raged for centuries, like Jupiter's great red spot, a vortex larger than Earth. Beyond them drift the frozen worlds, Neptune and Uranus, blue and distant, their atmospheres tinted by methane, their winds faster than sound. And beyond even these, at the edge of the solar system, lie icy bodies like Pluto and Eris, orbiting in slow, lonely paths through the Kuiper belt. Further still, comets trace elongated orbits, carrying ancient ices that predate the planets themselves. When they pass near the sun, they release tails of vapor and dust that stretch for millions of kilometers, glowing reminders of the solar system's earliest days. For centuries, humanity believed this system was unique, but in 1992, astronomers discovered the first planet orbiting another star, an exoplanet. Since then, thousands more have been found, some larger than Jupiter, some smaller than Earth, many orbiting suns very different from our own. One world circles its star every 2 days, so close that its atmosphere boils away into space. Another drifts in eternal darkness, having been ejected from its solar system long ago. There are planets that rain-glass sideways worlds with diamond cores, and others entirely covered by oceans deeper than any trench on Earth. Each one, in its own way, fulfills the universe's quiet promise that from dust, infinite forms may arise. Our instruments, the Kepler Space Telescope, the Transiting Exoplanet Survey Satellite, and the James Webb Space Telescope have revealed more than just numbers. They've shown us the staggering creativity of nature, the endless variations of temperature, pressure, and chemistry that define the possible. Yet among all these worlds, one still stands apart, not for its size or brilliance, but for its balance: Earth. A small, rocky planet at just the right distance from its star, not too hot, not too cold. Its surface bathed in liquid water, its atmosphere both protective and nourishing, its magnetic field shielding it from cosmic winds. Everything about Earth speaks of equilibrium, the same equilibrium that defines a star or a galaxy or the curve of space itself. It is easy to imagine that we live in isolation, but in truth we are part of an ancient lineage of creation. The atoms in the ocean were once scattered among interstellar clouds. The iron in our blood was forged in the death of stars. The air we breathe was shaped by cosmic processes older than memory. When you stand beneath the night sky, the stars above and the ground beneath are not separate stories. They are continuations of one another. Matter reassembled, energy transformed, consciousness awakening within the pattern. Planets, like stars, are part of this unbroken flow. They are the quiet result of cosmic patience, the universe learning how to rest, how to hold stillness in form. And though we often think of space as empty, it is in truth full of motion, dust potential, and quiet meaning. Even now, in distant nebulae, new stars are being born, their disks forming new worlds. Somewhere, oceans are condensing. Somewhere, continents are cooling. Somewhere, light is touching the surface of a world for the very first time. From dust to stone to life, the cycle continues. And all of it, every grain, every atom, every whisper of gravity, follows the same soft rhythm: expansion, creation, transformation, rest. You are listening to that rhythm now. It flows through your pulse, through the breeze outside, through the orbit of the moon. It is the same rhythm that shaped the stars, that sculpted the planets, that taught the cosmos to build and to wait. From the smallest grain of dust to the brightest sun, the universe remains in harmony, a slow, unending breath of becoming. There is a secret that lies beneath the visible cosmos. Everything we see, every star, every planet, every atom of dust, is only a fraction of what truly exists. The light that fills the sky, magnificent and infinite as it seems, is just a thin veil over a far deeper mystery. Most of the universe is invisible. When astronomers began mapping galaxies across the sky, they noticed something strange. The stars on the outer edges of galaxies were moving too fast. According to Newton's laws, the galaxies should have been torn apart by their own motion, but they weren't. They were holding together, spinning gracefully, their structure intact. Something unseen was keeping them whole. They called it dark matter, not because it is dark like shadow, but because it neither emits nor absorbs light. It is invisible to every wavelength we know. And yet, by its gravity, it reveals itself. We cannot see it, but we can feel its presence in the way galaxies rotate, in the way light bends around clusters, in the grand architecture of the universe itself. Like scaffolding beneath a vast building, dark matter shapes everything, holding galaxies in place, linking them in an unseen web that spans the cosmos. If we could see it, the night sky would look different, not dotted with stars, but veined with glowing filaments of invisible mass, stretching for billions of light years. Galaxies would appear like pearls strung on threads of gravity. Between these filaments would lie enormous voids, regions nearly empty, quiet and cold, where the pull of dark matter does not reach. Scientists estimate that dark matter makes up about 27% of the universe. while everything visible, stars, gas planets, and life, accounts for less than 5%. The rest, nearly 68%, is something even more mysterious: dark energy. Dark energy is the opposite of gravity. Instead of pulling things together, it pushes them apart. In the late 1990 seconds, two teams of astronomers studying distant supernovae discovered something that changed our understanding of the cosmos. They expected to find that the universe's expansion was slowing down under gravity's influence. But what they found was the opposite. The expansion was speeding up. The galaxies were drifting away from each other faster and faster, as though driven by an unseen wind. To explain this, they proposed the existence of dark energy, an invisible pressure woven into the fabric of space itself. As the universe expands, more space comes into being, and with it more dark energy. It is a quiet acceleration that will continue for billions of years, stretching the cosmic web thinner and thinner until galaxies drift beyond one another's sight. The more we look into the darkness, the more it reveals itself as a presence, not an absence. When we speak of the invisible universe, we are not speaking of emptiness. We are speaking of the hidden structure, the vast silent framework that holds everything we know. Even light itself, the most revealing of messengers, is shaped by what it cannot illuminate. When it passes through regions rich in dark matter, it bends a phenomenon known as gravitational lensing. This bending distorts the images of galaxies behind it, creating arcs and halos of light. In these distortions, astronomers can map what cannot be seen. It is as though the cosmos leaves fingerprints, subtle impressions that tell us of what lies beyond sight. Every telescope, every detector, every new instrument we build extends our vision further into this invisible sea. Yet, the more we uncover, the more we realize how little of the universe we can truly perceive. The visible cosmos, with all its light, color, and wonder, is merely the surface of something infinitely greater. Still, this mystery is not cold or alien. It is intimate, almost gentle. For even here in the unseen realms there is order. The dark matter web is not chaos. It is harmony, pattern, and balance on a scale too vast for imagination. It is a reminder that existence is not limited to what we can observe, that the invisible too has beauty. Even within our own galaxy, the unseen plays a quiet role. The space between stars is not empty, but filled with a tenuous mist, the interstellar medium composed of gas, dust, and fields. It is from this unseen reservoir that new stars are born, continuing the endless cycle of creation. The universe, it seems, hides its work in shadow, revealing only the surface of its artistry. And perhaps this is necessary. If all were visible, there would be no mystery, no reason to look upward in wonder. The invisible keeps us searching. It keeps us curious. It keeps us awake beneath the stars, asking questions that may never have final answers. To sit with mystery is to sit with the universe itself, patient, ancient, and kind. Every photon that reaches your eyes tonight has traveled through invisible space, past unseen matter, across billions of years. You are receiving not just light, but the echo of that which cannot be seen, the gentle fingerprint of the unknown. And so the invisible universe is not an absence of knowledge. It is the canvas upon which all light is painted. It is the silence that gives shape to the song. If you close your eyes now and imagine the cosmos without light, only gravity, only motion, it would not vanish. It would still be there, moving in quiet equilibrium, waiting for the next burst of starlight to reveal it again. This is the beauty of science, that it can describe what we cannot see and yet remain humble before what remains unknown. The invisible universe does not hide from us out of cruelty. It simply exists in frequencies beyond our reach, reminding us that perception is not the limit of reality. Somewhere right now, light is bending through unseen filaments of dark matter. Somewhere a galaxy is moving faster than it should, guided by forces we have only begun to understand. And here, beneath all that mystery, you are listening one small consciousness, tracing the patterns of infinity. The visible and the invisible are not separate worlds. They are layers of the same reality, the seen and the unseen halves of a single, endless whole. And in that harmony of light and dark, the universe continues to breathe. There are places in the universe where time itself loses its shape, where light, that most faithful traveler, is caught and never returns, where gravity folds space so completely that direction, distance, and motion no longer have meaning. These are the black holes, the quiet paradoxes of creation. They begin like stars, and they end like silence. When a massive star exhausts, its fuel fusion can no longer resist gravity's pull. The core collapses, atoms crush together, and all the matter that once radiated light falls inward, compacting beyond imagination. The collapse does not stop at density, or heat, or pressure. It continues until it becomes something the language of physics can barely describe. A singularity, an infinitesimal point, where mass and gravity become one. Around it forms an invisible boundary, the event horizon, the point of no return. Anything crossing it, even light, cannot escape. To an observer at a distance, this region appears perfectly black, outlined only by the glow of matter spiraling toward it. Black holes were once thought to be mathematical curiosities, strange consequences of Einstein's equations. But now we know they are real, abundant, even essential. They exist at the centers of galaxies, anchoring billions of stars in their orbits. Our own Milky Way harbors one at its heart. Sagittarius A times a supermassive black hole, 4 million times the mass of the Sunday. Around it, stars whip through space at incredible speeds, tracing invisible arcs through curved spacetime. Yet despite their power, black holes are not destroyers. They are transformers, places where the known laws of nature approach their limits, and where matter, energy, and time are woven into something new. When material falls toward a black hole, it does not plunge directly into darkness. It forms a swirling disk, heating to millions of degrees as friction tears it apart. This accretion disk radiates light so intense that it can outshine entire galaxies. From the poles of some black holes, narrow jets of plasma shoot outward, stretching for thousands of light years, brilliant pillars of energy carved into the void. These jets are among the most powerful phenomena in existence. They carry matter and radiation far beyond the galaxy's core seeding space, with energy and shaping the evolution of cosmic structures. In 2019, humanity saw a black hole for the first time. The Event Horizon Telescope, a network of radio observatories spread across the Earth, captured an image of the supermassive black hole in the galaxy M87, a dark circle surrounded by a glowing ring of fire. It was not just a photograph, but a window into the heart of gravity itself. The light we saw in that image was ancient photons, twisted by gravity, spiraling around the event horizon before escaping toward Earth. Their paths had been bent by space-time so deeply that they became mirrors of the cosmos's own curvature. To look at that image was to gaze at the edge of time. Near a black hole, the rules of existence begin to change. Time slows in its presence. If you could hover near the event horizon, you would see the universe outside racing forward while your own clock slowed to a crawl. In theory, a single minute for you could be 1,000,000 years for the rest of the universe. This is not imagination. It is the geometry of reality itself, predicted by general relativity and confirmed by observation. The stronger the gravity, the slower the time. What happens beyond the event horizon remains one of the greatest mysteries in physics. Do matter and energy simply vanish? Are they preserved, somehow hidden in new dimensions? Stephen Hawking suggested that black holes are not completely black, that they emit faint radiation known as Hawking radiation as quantum effects near the horizon cause particles to escape. Over eons, a black hole could evaporate entirely, releasing its energy back into space. If this is true, then even the darkest places in the universe are not eternal. They too transform, return, and recycle. Imagine that even in the deepest silence, the universe finds a way to sing again. Some theories suggest that inside every black hole may lie the seed of another universe, expanding in its own dimension, invisible to ours. In this vision, black holes are not ends, but beginnings, portals, through which creation renews itself endlessly. Perhaps every universe gives birth to others, each contained within the hearts of collapsing stars, each carrying forward the pattern of energy and light. We cannot yet know if this is true, but what we do know is that black holes are not errors in nature, they are its purest expression of balance. They remind us that even collapse has purpose, that endings are not absence but transformation. In their silence, there is wisdom. When light approaches a black hole, it is drawn in faster and faster, its wavelength stretching its color, reddening until it fades from sight. Yet just before it vanishes, it becomes beautiful, glowing, with a final burst of radiance as it spirals toward oblivion. That moment, that edge between being and non-being, is the frontier of science and philosophy alike. To look upon a black hole is to face the limits of human understanding, to see where the language of mathematics gives way to awe. And still, they are part of the same universe we inhabit. The same laws that guide falling leaves and ocean tides also shape these cosmic abysses. If you could stand safely at a distance and watch a black hole, you would see more than darkness. You would see reflection, the bending of light from stars behind it, forming a perfect sphere of distorted images. It would look like the universe wrapped around itself infinity, gazing back into infinity. Black holes are reminders that the cosmos does not fear contradiction. It can hold light and darkness in harmony, motion and stillness in one gesture. They are not the end of time, but the pause between its movements. Perhaps then the lesson they offer is not about destruction, but about surrender. The quiet acceptance that even light must rest, that even time must bow. In their depths, there is peace, a stillness beyond comprehension, a silence so complete that it becomes beautiful. And somewhere within that silence, perhaps the next universe is already beginning to breathe. The story of the cosmos is vast, yet like all stories, it too has a rhythm, a beginning, a long unfolding, and eventually a gentle fading. We often think of the universe as eternal, but it is a living process flowing through time like a river that widens, slows, and finally merges with the quiet sea of infinity. Even now, it is changing. The stars that fill the night sky, bright, steadfast, ancient, are not forever. Each one burns with fuel it cannot renew. Over billions of years, hydrogen will be consumed, fusion will slow, and the stars will begin to fade. The youngest will outlast us by trillions of years, but even their light, patient and constant, will one day dim. This chapter is not about loss, but about transformation, the long, tranquil future that awaits everything that ever was. Imagine time not in centuries or millennia, but in scales so vast that language begins to dissolve. Imagine a night that lasts 1,000,000,000,000 years. Imagine a dawn that never comes yet, still holds beauty. This is the far future of the universe. The era when creation gives way to stillness, when energy softens and the cosmos enters its long twilight. In about 100 billion years, galaxies beyond our local group will fade from view. The accelerating expansion of space will carry them away faster than light can reach us. The night sky, once teeming with billions of galaxies, will grow empty. To future observers, if any remain, the universe will appear small, quiet, and solitary. The grand structures of today will vanish beyond the horizon of visibility. But within that shrinking island of stars, life will continue its slow and graceful cycle. New stars will still be born, though more rarely as the gas needed for their creation grows scarce. The remaining light will turn redder, softer, older. In time, even the galaxies themselves will begin to fade. After about 100 trillion years, the last generation of stars will flicker out. What remains will be the degenerate era, a time of remnants. White dwarfs will cool into black dwarfs, faint and cold. Neutron stars will persist tiny and dense, whispering faint magnetic echoes. Black holes will dominate the darkness, their silent gravity ruling what is left. The universe will no longer shine, but it will still exist, a cosmic ocean of invisible energy and memory. And yet, even this is not the end. Over unimaginable spans, stretches of time, so long they defy comprehension, even black holes will begin to fade. Through Hawking radiation, they will slowly release their mass as energy evaporating into nothing. A supermassive black hole, like the one at our galaxy's center, will take about 10 to the power of 64 years to disappear a number. So immense, it outlives stars, galaxies, and all traces of life. One by one they will vanish, leaving behind a universe filled only with faint particles, and the last traces of light photons stretch so thin they no longer interact, drifting endlessly through infinite darkness. This is called the heat death, or Big Freeze, the final quiet equilibrium, when everything has expanded, cooled, and settled into stillness. But stillness does not mean absence. It means completion. It means the music has played its final note, and the air still trembles softly with its memory. Even as the cosmos approaches, this quiet, its beauty remains. For in every fading photon is the record of all that ever was the galaxies, the stars, the lives and thoughts that once looked up and wondered. The universe carries its story within its own light, even as that light fades. And perhaps deep within that silence, the cycle may begin again. Some theories suggest that the universe could one day reverse its expansion. A slow contraction, a big crunch, leading to another explosion, another beginning. Others imagine the birth of new universes budding from quantum fluctuations, each one with its own laws, its own stars, its own stories. Whether or not there is another dawn, the truth remains. Nothing is truly lost. Energy only changes. Form matter only rearranges itself. And even the emptiness is filled with potential. We live in a moment between eternities, a brief, luminous pause in an infinite sequence of transformation. It can be comforting in a way to know that the universe will continue long after us, that it will unfold in its own time without need for witness. But it is even more humbling to know that for this brief interval, we are here conscious, aware, and able to see it. Our lives measured in decades are like sparks in the cosmic dark, and yet those sparks carry within them the same energy that lit the first stars. In your body, in your breath, in the warmth of your skin, are atoms forged billions of years ago in stellar cores. Those atoms will one day drift apart again, becoming dust, and perhaps someday light. You are not separate from the universe's story. You are a sentence in its long, beautiful poem. The long future of the universe is not a tragedy. It is serenity, the slow settling of existence into balance. The great fires will cool, but their memory will linger in the shape of space, in the pattern of the cosmos, in the quiet hum that remains after sound fades. If you close your eyes now, you might feel it. The universe breathing slowly, calmly, endlessly. Expansion and rest, birth and dissolution, energy and silence. The rhythm continues, even beyond time. In that rhythm, there is peace. And perhaps that is the ultimate lesson of astronomy. Not that everything ends, but that everything changes. And in changing, everything belongs. Light will fade, yes, but in its fading, it will stretch into eternity, whispering forever the story of what once was. And long after the last stars have dimmed, long after galaxies have scattered the essence of the universe, its harmony, its balance, its quiet will still remain. A presence without sound, a vastness without edge, a silence that holds everything. Beneath the infinite sky, under the same veil of stars that has covered Earth for billions of years, the story of the universe finds its quiet reflection in us. For all the immensity of space, for all the grandeur of galaxies, the cosmos has, in this small blue world, found a way to look back at itself. When you stand beneath the night sky and gaze upward, you are not looking into emptiness. You are looking into history, into origin, into memory. Every shimmer above is ancient light. Some of it, having traveled for millions, even billions of years, to reach your eyes. Each photon is a messenger carrying the story of a star's life, its energy, its transformation. That light does not simply touch your eyes. It enters you. It becomes part of the chemical and electrical symphony within your body. The universe is not just around you. It flows through you, constantly. You are in truth made of it. The hydrogen in the water you drink was born in the first few minutes after the Big Bang. The oxygen you breathe was forged in the core of long-dead stars. The calcium in your bones, the iron in your blood, the carbon in your cells, all were created in ancient furnaces of light, scattered into space, gathered into dust, and reborn as you. Every breath you take is cosmic history continuing its cycle. When Carl Sagan said, "We are made of star stuff," it was not poetry alone. It was a statement of deep scientific truth and an even deeper wonder. For the same laws of physics that govern distant galaxies also shaped your heartbeat. The same particles that dance in the nebulae dance now in your blood. We are not observers of the universe. We are participants in its unfolding. Our consciousness, fragile, flickering, and brief, is the latest expression of that same energy that burst into existence 13.8 billion years ago. Through us, the universe has found a way to understand itself, to reflect, to wonder. When you look up at the stars are in a way looking back. It is easy to feel small when facing the vastness of space, to imagine that our lives are insignificant against such scale. But smallness is not the same as unimportance. A single photon, after all, can cross the universe. A single atom can become part of a planet, a tree, or a thought. In every human being, the cosmos has folded itself into awareness, and that awareness, no matter how fleeting, is luminous. It is the same light returned to itself. Perhaps that is the greatest revelation of astronomy, that separation is an illusion. The stars are not distant in any true sense. They are within us, as we are within them. The boundaries we draw between self and sky, between living and non-living, between the observer and the observed, are temporary arrangements, moments in the universe's endless motion. Everything flows together, everything breathes as one. And so, when you rest beneath the night sky, you are resting within your own origin story. The darkness above is not void, but womb filled with quiet creation. The starlight that reaches you tonight began its journey before there were continents, before there were oceans, before there were names. It has crossed all of time to arrive in this instant, in this one small, perfect moment of awareness. Let it in. Let it remind you that nothing is ever truly lost. When the stars you see tonight have faded, their light will still be traveling, still crossing space, still existing somewhere. In the same way, when our own lives come to their natural end, the energy we carry will continue, changed, dispersed, transformed, but never gone. In physics, this is a principle. In the heart, it is a comfort. Everything returns to the whole. The light that burns in a star also glows in your thoughts. The same balance that holds galaxies in motion governs the quiet rhythm of your breath. The same laws that curve spacetime guide the arc of your own becoming. You are an expression of the universe's equilibrium matter, given shape consciousness, given voice, light, given rest. And though your existence is brief in cosmic terms, brevity does not lessen meaning. A sunrise lasts only moments, yet it transforms the sky. A single note fades quickly, yet the song would be empty without it. We are the fleeting lights in the universe's long night, and that is enough. Even as the cosmos moves toward its slow, inevitable stillness, life's brilliance will echo in every corner where starlight once fell. The memory of being, of warmth, of thought, of wonder will remain written into the fabric of time. Perhaps eternity is not an endless duration, but a single complete awareness, the quiet realization that everything belongs and always has. So tonight, as you breathe slowly and the world around you softens, remember that the same forces that shaped the galaxies are shaping you now. The atoms in your body once burned in the heart of stars. The thoughts that drift through your mind are made possible by the same laws that govern the motion of worlds. You are not beneath the universe. You are within it. You are not watching creation. You are creation awake and aware for a brief and beautiful while. When you close your eyes, the light does not end. It continues within, in the quiet firing of neurons, in the warmth of your skin, in the gentle rhythm of your pulse. The universe too has a heartbeat, and you are part of it. And when you open your eyes to the night sky again, remember, you are seeing the oldest light there is. And in that light, you are seeing yourself, the continuation of the first dawn, the echo of the first fire. All of existence, from the first spark to this present breath, is one unbroken moment. In that realization, there is peace. Let it linger. Let it rest within you. For tonight, and for as long as you breathe, you are home among the stars that made you, within the universe that carries you, surrounded by the light that never truly fades. Thank you for listening. May your dreams drift gently among the stars.